My name is Ashish. I am the quality engineering practice lead in ING Bank. And every weekend, or at least before the start of the weekend, I get a summary of all the production incidents that ING receives or has faced for that entire week from the global CIO. And of late, the trend has been, like, I keep scratching my head, why do I keep seeing integration issues in production? Functional issues, not that much. Accessibility issues, not that much. But a lot of integration issues. And I've been thinking, is this only in our organization or is it across, right? And started to do a bit of research, and I found out, not just in the banking sector, but every industry which uses a lot of microservices, forget about microservices, a lot of interactions or interfaces, they all suffer from the same issue. And I thought, why don't we come here and talk about a topic which we are trying to implement in the bank. I'm not sure whether the benefits will be immediately seen in the next few months, but I would like to use this talk to also get some feedback from you, what you think about contract testing. So that's the main motive of today's talk. So in 1999, there was a major incident that happened as well, but not in a bank, in NASA. So what they did was they had the Mars climate orbiter, and they sent it after 9 months of preparatory work. As soon as it entered the atmosphere of Mars, it just vanished. Everything crumbled. Do anybody know why?
They mixed up imperial and metric.
Spot on. So one of the systems, they were sending inputs in imperial units, and the other one was expecting metrics. Such a small expectation could not be fulfilled when the entire system was on the ground. They only realized it after entering the atmosphere of Mars. And that eventually cost $327 million. Yeah, quite a costly miss. But the same problem, or at least the likes of it, is seen today as well on our daily work, right? 1999, unit assumption, but in our daily work, we have schema assumption. Right? I'm building a microservice, an API, you are building an API. We are assuming that whatever you're going to send, if you're a provider, whatever you're going to send, whatever I'm expecting I'm going to receive, are more or less the same. And we are running the entire bloody show based on assumptions. Some are doing great, not judging on assumptions, but on concrete contracts, but not everybody, right? If you notice, the bug was not in the code. So you, as a developer, may have written the best quality code, but it was only on the fact that I did not do a proper handshake with the other system. I'm a provider or a consumer, I did not do a proper handshake. That was it. And contract testing essentially ensures that this handshake is solid. Anybody familiar with contract testing? A lot of hands. Are you experts in contract testing? Yeah, okay. So today what we will try to do is we're going to take some few examples and we're going to try to do a practice together and see if this is useful. By the way, even in ING, it's not that we are doing great on this topic, but at least we can discuss if we are on the right track or not. Now, so many times we have seen all tests are green. And by tests, I mean, yeah, sure, we have done our unit tests. Yes, sure, the business has done their end-to-end tests. They are all green. But still, we see integration problems in production, like I have to deal with every weekend. Why weekend? I don't know, but every weekend. I mean, I get the report Friday evening, and then it kind of keeps bugging me. The whole weekend goes away. This is the real question. Microservices, when it came into being, it promised independence. I, as a provider, I'm going to do my stuff. You, as a consumer, you're going to do your stuff. We will be independent of each other, right? We have this Swagger, the open API spec, right? That becomes a single source of truth. I do my stuff, you do your stuff, and we are on our way. We deploy merrily. But that just did not happen purely because we, somewhere down the line, we have to talk to each other. And that conversation or that handshake creates that silent bonding that needs to be taken care early. Otherwise, we keep on finding it at a very late stage in our SDLC. Now, because I'm the quality engineering practice, one thing that I have to do it on a regular basis in my organization is to make it very, very explicit what are the different stages of quality engineering or testing. Me as a developer, I am intimately close to my code. I'm doing unit testing. Great. So I'm on my laptop. And then I need to be able to do a handshake with my other neighbors. That's also probably doable on my laptop, but mostly done on a CI level, so the CI environment. Then I form a package, and the package gets deployed to an environment. That's where CD kicks in. Any defect that is found in the CD environment is expensive for us. If we did not catch it at a CI level, then we have a problem. Then that becomes an expensive problem. The rule of thumb is the cost of fixing a defect per environment or per stage increases by 10 times. So if I could have found a defect and the cost of fixing it is $10, if I didn't, and if it is found at a much later stage, maybe 3 environments down the line, then it is automatically $1,000. So we need to shift left, find it early. That's the main message. But end-to-end tests, they do work, but they are not meant to test these contracts. I am not against end-to-end tests. Sure, you need to do that. But you need to use end-to-end tests to test business flows. You cannot abuse end-to-end tests to test your technical code, your units, or your handshake. So end-to-end tests are not at all meant for meant to replace contract testing. And if there is a thought in our mind, yeah, sure, the QA team will catch it. Let me just ship it. We are doomed. Sure, the business users are going to catch it. We are doomed. There is no way that they will be able to traverse through all possible combinations of API handshaking through their end-to-end tests. They're not meant for it. They're brittle, and they are bloody expensive. So here's a shift in thinking that I want you to think along. Instead of thinking from testing the system, we need to start testing or guaranteeing the interface. So not an entire system in its entire bounded context, but just the interface. Because the real power is if you are able to ensure that your interface works well, 90%, statistically, 90% of the issues in production will be eliminated. How do I say 90%? Because in our bank, we have been doing what is called a systemic causal analysis. Over the last 1.5 years, we have been going through all the incidents that we found in production and all the defects that we found in production -1, which is staging. And from all the details that we have gathered, 90% of them are interaction issues or interface issues. So if you fix them, 90% is likely to be fixed. Of course, there's a slight caveat. Your context may vary from my context. Just think along. So what is contract testing, or what does it essentially ensure? It ensures that the request structure is maintained, the response structure is known to us, the status code is also known to us, so there is a handshake on that, the required fields and the optional fields, and behavioral expectations, right? Both sides, both the provider and the consumer, they independently do their tests based on these contracts without spinning up a full environment, but spinning up their own ephemeral environments, the little environments to do the test on. Needless to say, the feedback is much faster than end-to-end tests. Now, the question is, who defines these contracts? So, obviously, it's on the screen, the consumer does. If I'm a provider, and if you're a consumer, you're going to come and tell me, hey, I need this from you. I'm going to see, okay, do I think I can deliver this? Okay, sure, I'm going to deliver this to you. But before I deliver this to you, I'm going to do a little test myself that, yeah, I'm sending it correctly to you. And then you can go your merry way, I can go my merry way. This little thing that I have in my hand is the contract. So a consumer defines the contract. And it specifies what it needs. It encodes its expectations in the form of a JSON file, in this case contract, and the provider tests against it. Why do we think contract test works or can work? What do you think? From your experience of what you have been doing in your organization, why do you think it works? Fast feedback, yes. Other points? Early detection, yes. Other points? It helps the conversation, spot on, yes. There is nothing vague about it. It's just in a JSON, so it helps in making the conversation robust. Early failure detection, a lot of you said this. Reduced coordination, right? You said helps the conversation, so that's reduced coordination. And clear ownership on boundaries. And without contracts, you're always thinking, can I deploy? Will I break somebody else's build? But with contracts, you're way more comfortable. But here's another thing. Change will happen. You will need to evolve your schema. You will need to evolve your APIs. But then, does this contract enforce a kind of failure every time there is a change? No, right? Because technically what the contract says is, okay, this is hard bound. If I make a change, it's going to fail, the whole bank is going to, or the whole organization is going to cry over it. No. Change will happen. There are certain best practices to make those changes assimilate in the process. We're going to go through those best practices. There are many. I have highlighted or shortlisted 4 of them. First one is, make the changes additive. And that is safe. And not just non-additive or subtractive. What does that mean? Just this is just an example because we're going to go through this entire contract testing flow. As of now, just know this, that if you have this remaining daily limit, remaining daily limit tag, In the next one, we are renaming it. So if you want to have a better name, a logical name for a tag, it is okay to have, but then have two, remaining daily limit and remaining limit, instead of just simply eliminating one of them. Because if you do, you're immediately inserting a breaking change, and feel free to remove this once everyone or all your consumers have migrated to your target solution. So this is basically making it backward compatible. This is one example. Another example is, and this is the beauty of contract testing, I, as a provider, can have multiple consumers. So you are a consumer, you are a consumer. A field that is relevant for me may not be relevant for you. So you have the option of marking certain fields optional as well. In that case, I don't break your contract, and the other way around, I don't break your contract. In this case, look at this reason code. For the first one, the reason code is optional for one of the contracts. For the next one, it is mandatory. So both are valid. In one contract, the reason code remains. The other contract, the reason code may be omitted. And if I have changed the name of reason code to something else or type or whatever, I'm sure the optional relationship will never break. And finally, make sure that the testing is done against all published contracts, not just one because I'm your friend, or this is an easy neighbor to work with. If we have difficult neighbors as well, make sure that the contract tests are done against all published contracts. But how do we do that? Within ING, we're trying to do this with Pact. Pact is the de facto tool for doing contract testing for REST APIs mostly, but also for events. Anybody else who's using any tool other than Pact?
Well, we created a custom solution because we wanted to do contract first.
Cool. Cool. And Pact users? Thought so. I do not have a very love affair with Pact, to be honest. So it's not that I'm going to go all gaga about Pact. But some of the things that are really nice about Pact is you can do consumer-driven. Sure. Recently, and not recently, few years, they have also introduced what is called bi-directional contract testing, two-way. And it's language agnostic. So whether you're doing building APIs in Python or Java Spring Boot or Node.js, doesn't really matter. You can still use Pact the same way. Also provides provider verification, and we're going to see it. And they also provide a Pact broker. So this custom solution that you have built, do you also have a broker where you publish your contracts? Clever. Yeah. Now, if you look at the workflow looks like this. So the consumer writes the contract tests. Okay. The contracts, so writes the contract tests. From those contract tests, a contract is created. A JSON file is created. Now, these contracts are then pushed to the Pact broker. The Pact broker is essentially a registry for these contracts. That's all it is, a registry. Like Docker, a Docker registry, contract registry, that's Pact broker. Provider then runs a verification on his end. And the provider, after running the verification, says, okay, I'm good, now I'm ready to push. And then there is a CI/CD gate that comes in. The gate is called, for Pact, anybody knows the name of the gate? it says, can I deploy? That's it. That's the name of the gate. Can I deploy? And if the answer is yes, and I'm going to show you how it can be yes or no, then sure, you can deploy. If the answer is no, you can't. So that's it. Consumer creates the contract test, produces the pact. The pact is pushed to the broker. The provider tests against the pact. And then the provider says, can I deploy? And then yes or no. So we have two pipelines, the consumer pipeline and the provider pipeline, right? Two pipelines, independent pipelines, but all talking to one pact broker. Now let's take an example. A very recent example from my organization, ING Bank. Yeah? Instant payments. So I'm going to transfer $10 to you, and let's see if it gets transferred. No, we're not going to see that, but my point is, instant payments is something that cannot undergo any kind of risk or assumptions. It has to be absolutely deterministic. Now, the consumer in this case is a payment orchestrator, and the provider is a limits and risk service. So the payment orchestrator here, before sending the money, will ask the limits API, hey, can I transfer $10 to this person? The limit says, yes, you can, because there is available balance. Or you can't, because there is no available balance. Okay? But usually, there's not just one consumer, there is going to be another consumer. In our organization, one provider is probably talking to at least 70 to 80 different consumers, right? But we're going to make it more complicated as we move forward. Let's first start with one consumer, right? So the consumer is saying, am I going to be able to transfer? It's going to say yes or no. And if something goes wrong, the customer is going to be really mad because he's not getting the money. And if something goes wrong from this provider side, then we can even end up having a fraudulent transaction. So we need to be absolutely deterministic. There is zero margin for error. One of the things that we can do is, sure, we can go ahead and do an end-to-end test, but in this kind of a flow, an end-to-end tests is detrimental. Can we do a mock test? It can potentially be non-deterministic, right? It can be a bit fluffy. Contracts may not be solid, and there could be a potential drift from a real situation. In this case, pact is absolutely the only solution, or contract testing is essentially the only solution. So we will generate a pact file, and the provider will have to test it. This one line, I keep on repeating this, is something that I have mentioned or put throughout the presentation, and that is, a pact is an artifact. Treat it like an artifact, a testable artifact, like your code. The artifact is very, very important. It is an executable. It has as much importance as anything else in your entire Git repository. So let's first establish the premise. Premise is going to be this. I'm going to make a post call with the account ID, the amount, currency, channel, and payment type. And the response that I will get is going to be a JSON allowed with a remaining daily limit and a response code, which is optional. On the right-hand side, this one is an OpenAPI spec that essentially describes this whole interaction. Response 200, the schema shows that the required fields are allowed and remaining daily limit. And the properties of these are Boolean, the other one is number, the other one is string. Yeah? Straightforward premise is done. Now, step 1. The consumer defines what it needs. The consumer defines what it needs. What does it do? It uses the packed DSL. So I'm using Java Spring Boot in this case. You can use your programming language. So there are two things, what it needs, and then also, if you remember the workflow, it also needs to generate the pact, which has to go to the pact broker. Yeah? So let's look at this. The first one, given account has sufficient remaining daily limit. This is the state. This is the state, right? Account has sufficient remaining daily limit. And it says, when I'm going to do a post request with this endpoint, with the body, that's in that variable request, it should respond with status 200, but also with a response. So what is this body and what is this response? Let's have a look at it. I'm creating the body, the request here, the account ID with a regex, the amount, currency, and payment type. Yeah? And what is the response here? Allowed and remaining daily limit. Now, what is going to happen is, at this point in time, there will be a mock server that will be spun up. So, if you look at this example, the last line, it says to pact. To pact. This essentially creates a JSON file for me. So in my target folder, in my target pact folder directory, the JSON file automatically gets created. To pact is the line for me. But other than that, the consumer then spins up this mock pact server and runs the test against that mock pact server, assuming that eventually when that mock server will be the provider, everything will work. Yeah, which is this. The mock server is spun up, the request is sent, and the response is allowed. Right? Simple test. Now, at this point in time, as I just said, the artifact is created in the target folder. And if we look at the content of that artifact, that could be quite interesting for us. What does it say? It talks about who's my consumer. So the payment orchestrator is the consumer. And who's the provider? The limits risk service. So that's very important. Then it also talks about the state. If you remember, I told the state is account has sufficient remaining daily limit. So per every interaction that I'm doing, a consumer and a provider, the state is very clearly mentioned in the pact. Then it mentions the request and the response. Yeah? After this, if you are normally in a CI/CD pipeline, and if you have established a pact broker, then you don't have to do this. This process is pushing your pact into the pact broker. For you, maybe the one you have built a custom solution, it's just a git add, git commit, git push, possibly. But here, you have an option to publish the pact with a broker base URL, and you can also even tag it, and then it gets published to the broker. We don't have to do this locally. After the pacts are created, we just push it to our GitHub repository, and then the pipeline automatically pushes it to a pact broker. Now, here's where we are going to make it a bit more complicated. We're going to bring in another consumer. Okay? Now, this consumer, will also do the same thing, right? This consumer will also create a pact and will also create a test. So let's look at this one. It says account has sufficient remaining daily limit. That's okay. But this is interested in the third property, which is the risk band. Previous consumer was not interested in that property. But this consumer is interested in that property, risk band. So now the provider has to be very careful. Without just depending upon one interaction, it has to be careful that, okay, there's another consumer who's asking for an additional field, and that is risk band. Okay. Now, both these contracts or pacts are in the pact broker, and now the provider starts its activity. It's nothing, too deep. It's just that a simple Spring Boot implementation of this, but keeping in mind that when it will run the check, it will have to run the check. So now it's going to run the verification test. It will have to run the verification test against two contracts, both the contracts that are in the pact broker. Two kinds of tests. One is sufficient. So it just creates a test called sufficient, where it says, okay, if I have enough balance, I get the response. And the other one is exceeded, where I get the response as limit exceeded. And the first one is false. False is it allowed? No, so false. Now we are going to introduce a breaking change. Yeah, because so far it was a happy story, but now we are going to try to break it. The remaining daily limit will go away, and remaining limit is going to be the name of the field, because apparently the organization decided this is more understandable. But if I, as a provider, if I just remove it and add it, then both my contracts will break immediately. So what was one of the best practices that we said? We said we're going to make it additive. We're going to have both. So this is what it is. We are keeping both because this is where line number 3, consumers rely on this. And line number 6, this is the new field that has been added safely. So if I have a new consumer coming in, all my new consumers, they will start to use the new field, the daily limit, remaining limit. But all my old consumers, without breaking them, I would continue to use the old one. However, only till they are migrated. We're not going to eternally use it, but only till they're migrated. Let's assume for a second that we don't follow this best practice. We just make this change, and then we just publish it. Then what happens? Then this can I deploy kicks in. I was referring to this can I deploy, right? This can I deploy automated release gate, it kicks in. Now, there are 2 examples that I will show you how this can I deploy looks like in a packed broker if the internet works. I have to get the cursor there. Yeah. So if it is positive, and this is an example of the packed broker where the example app is marked in a red circle C. Can anybody tell me what that symbolizes? C, consumer, exactly. So against this consumer contract, the can I deploy is green. That means the contract is okay, everything works fine, I don't have to worry, the pipeline will go through. However, still struggling with the cursor. If I had introduced that change, then for that same contract consumer, the can I deploy will stop me. It will, of course, match a few things. I will show you when I come back to the original slide, certain tags, the branch, it will match it and it will say, no, you can't move forward because the contracts don't match. It says daily remaining limit, the other one says remaining daily limit. It is an enforced prevention of deployment. How do you do this in your organization, if I may ask?
Yeah, it's contract first, so slightly different setup. We publish the contract with a final version, and both the provider and the consumer have a Maven dependency on the contract.
Okay. Maven dependency. That got me curious. If you look at the code snippet over there, it talks about the version and the environment test. When these slides will be made available to you, you can also see that in the can I deploy screen, it also tests against, or it matches against the environment, whether I'm pushing to test environment or I'm pushing this version to acceptance or pre-prod or whatever. So the full consumer-driven contract testing sequence is like this, right? The consumer writes the pack test, consumer runs the pack test against the mock server, but then also generates the JSON packed file, which is an artifact, an executable artifact, and is pushed to the packed broker with a version tag. The provider then fetches these consumer packed, all consumer packs, and tests it, and then the can I deploy kicks in. If it satisfies, the deployment happens. If it is not, then the deployment is stopped. I quickly will explain a bit about bidirectional contract testing. I think it is very similar to what you have implemented in your organization. Bidirectional contract testing does not need the consumer to create the pact. The single source of truth is the OpenAPI spec. Based on that OpenAPI spec, the consumer contracts are created and the provider implementations are created. So this is a relatively new concept in the contract testing world, I mean. What it does is it eliminates the need to do this interaction play. So you don't have to interact all the time. Okay, the consumer gives the contract, the provider has to run the test. That is avoided because you're using the OpenAPI spec as your single source of truth. And from those OpenAPI specs, Swagger I mean, yeah, from those OpenAPI spec, the contracts are automatically generated. What we are even trying to do now is we are trying to make sure with GitHub Copilot, and also we are working with SmartBear to ensure that this entire process is AI generated so that the entire need to write contract tests is absolutely eliminated. And the engineers can just simply go about building the test without having, building the APIs without having the need to write the tests. So it's not there yet, but in the roadmap. Bidirectional contract test is mostly usable in a very large organization. But if you have a small organization, a small-ish organization, better off writing CDCT, that is consumer-driven contract tests. Quite a lot of text, but this is for your reference if you want to read through the slides later on. Yeah. There are some common objections to contract tests from our experience in ING. What would be your objection to contract testing? No, I don't want to do it. Why wouldn't you want to do it? Any one objection? Yes. Yeah, so, okay. So that's more like, okay, if I'm very close to my neighbor, I really don't have to go through the entire hassle. But in a normal situation where you're not close to your neighbor, what would still be your objection? Additional CI/CD setup? Yeah, okay. Yes, very valid point. How do you? Silly tests. Shitty. Okay. I have no idea if contract tests allows you the nature of the tests, because it's an interface level test, right? I don't know whether it allows you to write shitty tests. Unit tests can be shitty, but contract tests, yeah. Maintenance is another. Yeah, which is the line of bidirectional contract testing, right? Because that's where OpenAPI becomes the single source of truth. But in a large organization, if you only have OpenAPIs, if you do not have contract tests at all, the problems that we tend to have is you are relying on humans to have nice relationship. And that just doesn't work. But that the YAML will not stop you from preventing a deployment of a human error. Exactly my point. Yeah. It seems like the second one is where you are mostly heading to. It feels like extra work. It is extra work. Yeah. No, true. I mean, it is not an absolutely unheard story. Even in ING, from all the engineers who have been working with this, at the very beginning, it did seem like an extra work to all of them. Why are you forcing us to create a new kind of test? We are going to be mindful. We are going to be good people. We are going to do the necessary interactions. And we still have 17 incidents of integration issues in production over 1 month, 2 weeks. Right? So the last speaker here, he talked about enforcement. This is more or less an enforcement. Where it fits, microservices, APIs, and if you have events, event-based message interaction, and if you have a regulated environment, and if it is less useful if you have monoliths. or if you just do not want to do it and there is nobody who's asking you to do it, it is less useful. You don't have to do it. So the big shift, right at the very beginning, I talked about it. Instead of focusing on testing an entire system, we need to start focusing on trusting the interfaces or making them trustworthy. Key takeaways for me are these. For you, it could also be different. You can also think, hey, what the heck, don't care, but still, for me, these are the absolute 4 key takeaways. There will be more, because I am a student of contract testing in the sense like I'm learning from all the experiences and also making sure how can it be better and better and better over the next few months, years, so that the only objective that I have is integration issues should not be seen in production. That's it. It can be seen earlier, no problem, but not in production. Final thought, this is where I'm going to leave you with. Also the title of my talk, Stop Guessing, Start Trusting. Thank you.